In today's puzzle, we are to flip hexagonal tiles based on an input of paths to single tiles, giving a series of directions: northeast, east, southeast, southwest, west, and northwest. This means the tiles stand on a corner, so to speak. The problem is that the path is given as a string of 1 or 2 character step instructions without any spacing. So first we must determine what path of 1 or 2 letter instructions the path is actually made up of. The final goal is to apply all the interpreted flipping and count how many black tiles we end up with. Let's begin.
If you like my videos,
feel free to do nothing. Just grab a cup of coffee
And enjoy. So here's my solution to this puzzle. So what we basically do first is that we parse each line of the input, which is a problem of itself. Then we assemble this vector of vectors of all the tiles to flip. Then I sort them, but this is only for logging so that I can detect multiple paths that lead to the same end tile. Then we apply the flipping, which I do by counting how many flips there are, and then I accumulate all the black tiles by simply counting all the odd numbers. All the odd counts will be flipped to a black. All the even counts will go back to whites. And that's the basic solution. And the parsing is perhaps one interesting part of this. So what we do is we use a pre-assembled vector of combinations of directions or steps, and I suppose you can do this more efficiently, or I don't know if this is actually even needed, but what I did was that I assembled all the 64 combinations of the steps, but I did not include the permutations, so it's only the order they are given in the example. And well, it works. I will come back to this in part 2 and see if it's needed. So that's that, and then we have all these helper functions, which was a mess for me to get all this correct. We have to translate from this path code that I invented, which is a 6-bit binary number, and the settings in this path code is translated to these directions. So we have an enum up here with all the directions, and we skip these helper functions. We can go to the most interesting one, which is this one, which is one that takes the direction and returns a vector that represents the step we're going to take. And the final bug I corrected here was that going east in a hexagonal pattern means I must go 2 steps in the x direction and not 1. So I was searching that bug for eternity, but I finally figured it out. Well, now when part 1 is done, I can see it wasn't actually that complicated, but of course the devil's in the details. And if you want to, you can now watch me on a speed up manner live code this solution, and I see you at the end. finally figure out the final bug. These direction vectors had the wrong length. So going east and west is going 2 steps in the x direction. So there you have it, and now we get the correct answer and away to part 2. Thank you for watching and see you next time.
If you like my videos, feel free to do nothing. Just grab a cup of coffee
And enjoy.